Right, Bismillahirrahmanirrahim. Welcome to the second lecture on the Random Processes graduate course. Um, Last time we discussed just the main details of random processes, right? The idea of random processes, where you can use them, some interesting facts about that, and we also very quickly went through the different modules or the chapters that are there in our main textbook. Today we will start with the the foundation of random processes, which is of course probability theory, right? So what I covered today is a revision. Basically, all of you have at least taken one course in undergraduate in probability. So you should have seen all of these over there as well, and that's why I will um, take the allowance of going faster. Okay, what I cover here at this speed, usually we cover in 3-4 lectures in undergrad. But this is we have to get to the real topics or the more detailed topics. So but that does not mean that you cannot stop me or ask me to explain further or revise. Yeah, so we will see. um, it's going to be a series of questions. As I said, I like to interact, ask questions, so you have some few seconds to think about it. And sometimes you get the answer right, sometimes you get your guess is a bit off the mark, which is fine. But then I can give you the answer, or what I think is the answer. Right. So let's start here then. We will come back to randomness later, but for now, let's start with probability. Yeah. So, what is probability?
Probability is like a chance of occurring
Hmm.
to in an infinite case. जब हम किसी चीज़ को infinite तक approach करें then उसके occurrence का chance होता है. Let's suppose we toss a coin for an infinite
Hmm.
times, then
Hmm.
there is a probability that it comes to a head. So half I think you can say that.
Right. So what you are saying is more like assigning the probability, right? Doing lots of experiments so you can confidently assign the probability,
Yeah.
right? That's also good. What else can you think of? What is probability?
The chance of occurrence of an event.
Chance of occurrence. Right. I like to start with something even more basic. What you say is right, but I like to start with something even more basic, and I like to say probability is a lack of knowledge. Probably कब कहते हैं हम? Maybe. When do we say? If I ask you your height, आपको पता है?
5, 6,
अच्छा
5,
आपको वो भी maybe है. You should know your height. I know mine 5'10". Yeah.
7.
I don't say my height is probably 5'10".
Mm-hmm.
Right? Why? I don't lack knowledge on that. I know
Mm-hmm.
my height. Yeah.
Mm.
So what's the height of the next person who enters this room?
We don't know.
We don't know. There is lack of knowledge, right? So it's fair to say when you start going from certainty क्या है? Surety, यकीन.
Exactly.
Yeah. From certainty to perhaps, maybe, likely, हो सकता है, probably, right? Then you say, what's the difference between impossible and improbable? क्या होता है फर्क?
If there is no chance of occurrence, then it means impossible.
Hmm.
Then probable means there is a little chance.
Improbable is, so difference. What's the difference? Impossible is also is certainty. कोई lack of knowledge नहीं है. आप कह रहे हैं ये चीज impossible है,
Mm-hmm.
नहीं हो सकती, right? So, but improbable is like, yeah, it can occur, but the chances of happening are very low. Again, this is difference between
Mm-hmm.
pure knowledge and
Lack of
lack
knowledge.
of
Lack of
knowledge. Yeah.
knowledge.
अब वो philosophical discussion है, can we actually all have any time have pure knowledge even in your height, you know, कितने तक measure करेंगे, molecule level तक करेंगे, कहाँ तक? Yeah? So we could make things harder for ourselves, but we won't do that.
Just like
Right.
time, sir. That you cannot measure exact time actually. Just like
Yeah, yeah. So okay, probability is lack of knowledge. Now, why do we sometimes lack knowledge? What happens? क्यों lack हो knowledge?
We don't have information about some event.
Okay.
That's why.
So why wouldn't we have information about something? क्या causes हो सकते different causes हो सकते हैं
Yes.
what can you think of
Yes. Because the outcomes may be sometimes different from one case to another.
Hmm.
That is one of the reasons, because we don't have an exact knowledge that what comes, what.
what comes future
Yes, sir.
tossing a coin person coming in future है ना अभी तक कोई machine develop तो नहीं हुई future देखने की right
Exactly.
so one reason we sometimes lack knowledge is that the event hasn't happened yet
Mm.
if I say toss a coin before tossing it or while I've just tossed it I asked you is it heads or tails what's it gonna be is lack of knowledge and that is caused because it hasn't landed yet right or I haven't rolled it yet before rolling a die होता है ना लूडो में जो खेलते हैं die
Mm.
so before rolling it I asked you what's the chances that it will be an even number yeah there is lack of knowledge because event hasn't happened so that's one reason we may lack knowledge yeah future event what else और क्यों lack हो सकता
जो हम इवन परफॉर्म कर रहे हैं एक्सपेरिमेंट परफॉर्म कर रहे हैं वो हमारे पास श्योरिटी क्लियर नहीं है इवन दैट्स
So
मे
multiple outcomes can be.
variations हो सकती हैं उसमें yeah like I gave the example of the camera taking your face recognition thing to unlock right now they are in within your face there are variations from day to day right
Yes.
so there can be lots of variations जो आप बता रहे हैं उस experiment this is many different ways of talking about variations right in that thing yeah okay वो हो गया why else आप सोच रहे होंगे अब और क्या रहेगा अभी है अभी है कहानी बाकी है so what else
So multiple outcomes हो सकते हैं, like.
वो
we
तो हो
don't-
गया ना फ्यूचर हो गया ना आउटकम्स
अच्छा,
right
futures हो गए.
हाँ और अच्छा can I not tell the height of the person or the next person who enters this room बता सकता हूँ मैं किसी दुनिया में कोई है चांस लेट्स से फ्यूचर अभी डेवलप नहीं हुआ लेकिन okay what if I could have some technology where there is a very tiny drone following every human being on earth all the time ठीक और मेरे पास उनकी रिकॉर्डिंग आ रही है लाइव लेट्स से हाइपोथेटिकली yeah then I can on that camera see कि अभी कौन अंदर आने वाला है क्योंकि हर every person's feed I am getting through some drone or some technology yeah so then I can tell what will be the height of the person who is about to open the door जो ही वो उस पे हाथ रखेगा हैंडल पे I can see कि अच्छा ये बंदा है और ये रीडिंग आ रही है इतनी हाइट so sometimes we lack knowledge because collecting information is too hard last time we discussed the Brownian motion thing you could try to model exact positions of the atoms try to measure exact position of the atoms exactly when you threw the pollen grain in there right and then follow all laws of deterministic laws of physics you could do that but what's the problem कर सकते हैं हर एटम का अलग अलग एग्जैक्ट स्टार्टिंग भी देखना है कि जिस वक्त द मोमेंट द pollen grain hits the liquid उस वक्त what was each atom उसकी velocity क्या थी momentum क्या था उसकी location क्या थी size क्या था right so this reason is also very common in using probability theory and random processes there are many engineering applications physics applications where I can actually model the full thing okay and get exact results but it is so hard not just in terms of getting the sensors but also then calculating all of that इतने data आ जाएगा कौन calculate करेगा right so what do we go for averages mean behaviors to make things simpler because it's working it works for us yeah so future event that's one reason hasn't happened yet so I don't know I lack knowledge then there is variations in the nature of the things that happen thirdly um, we it's too hard to collect information there is a fourth one कोई है जिनमें चौथा क्या हो सकता है also why चौथा भी है कोई why do we lack knowledge and why should we lack knowledge? There is one fourth reason. Very interesting है and physicists should be able to answer mostly but mathematics में भी हमें पढ़ा तो होती है हमने चीज़ें sciences
लॉ वो अनसर्टेनिटी वाली चीज तो नहीं है सर वो जो एक
Heisenberg uncertainty
हाइजेनबर्ग
principle.
अनसर्टेनिटी प्रिंसिपल
Right. You know quantum physics?
Yes.
सुना तो होगा, yeah?
Yeah.
Right. You know Copenhagen consensus? सुना हुआ उसका? Right.
Heisenberg uncertainty principle.
Heisenberg uncertainty principle. Now, in quantum theory, there is this confusion whether this uncertainty is absolute, it's part of nature, or it's because of something we are lacking in our model or our instruments, right? Now, the current consensus of quantum physicists, which is called Copenhagen consensus because it was developed in Copenhagen, Neil Bohr वगैरह lead कर रहे थे. They concluded or they decided to say that our models are correct, everything is right. This is how small particles are. They have randomness. Okay, so at the very basic level, particles are fuzzy in their nature. So it's not like okay, we don't know exactly okay, where is the electron जो डेंसिटी फंक्शन बनता है श्रोडिंगर इक्वेशन से इलेक्ट्रॉन का राइट दैट व्हाट इज दैट दैट्स द प्रोबेबिलिटी ऑफ फाइंडिंग द इलेक्ट्रॉन राइट सो दे से इट्स एक्चुअली नॉट दैट we can find that exactly okay they say nature itself is like that कि वाकई उन सब जगहों में फैला हुआ okay because if they accept that interpretation then they can have this quantum entanglement का सुना आपने right so there are two particles you can entangle their spins then you take one of them to one side of the universe okay and if you uh, change or play with the spin of one particle instantly the other one is affected. Einstein didn't like that, he rejected it because that means it's like happening faster than speed of light instantly hoga that those things are don't seem currently they don't seem possible without accepting that nature on the very small level is uncertain. That's where Heisenberg uncertainty principle is also coming from. This consensus could turn out to be wrong, but currently there are no other models to explain. Yeah, so that's the fourth reason, more philosophical you could say, or it is there in physics. Um, Schrodinger and his colleagues said, let's not go into this, but just calculate the formulas, and the formulas say this and this, so it looks like everything is fuzzy over there. Now, why it is fuzzy, we don't know. Right, so quick recap, we lack knowledge, future events, too much variation, too hard to collect that knowledge. We could collect that knowledge, but it's too hard, so we just say, okay, let's simplify. Yeah. Fourthly, the quantum weirdness thing. Yeah. Right. So then, what is statistics?
So we can say the fourth one is variation in nature, like that.
Variations in nature. It's more than that. It's like the particle existing or seeming to exist in multiple places at the same time, right? So it's not a variation from one trial to the other. It's the spread over space in the same time, right? So इस पे आप पढ़ना थोड़ा सा detailed discussion है. And I can tell you this has baffled the biggest minds. Einstein said no, any month. But everyone else in quantum physics said, yeah, this is the conclusion so far, right? Okay, so then what is statistics? ये तो होगी probability, right? So what is statistics or statistical analysis? वो क्या होता है?
Collecting information, organizing information.
Organizing information, collecting information, good, right?
Dealing with numbers and analyzing the numbers
Produce
Numbers कहाँ से आ रहे हैं?
from
data.
maybe
Information
from the
जो
information, yes.
right.
To produce something results on the basis of data and information.
Right. So can I connect it to the first thing, lack of knowledge? और अभी आपने क्या कहा, information, data. Information और जो lack of information या lack of knowledge ये opposite चीज़ें हैं, ऐसे ही. So in probability there are situations where we lack knowledge, वजह मैंने बता दी different. But then statistical analysis, what does it do? It's our way of collecting information to reduce that lack of knowledge. Okay, I'll give you an example. If we lack knowledge, that doesn't mean our lack of knowledge is always absolute. I'll explain what absolute means here. What's the height of the next person coming in? I don't know, right? But there is lack of knowledge, right? But is that really absolute? Can I not say anything about the height of the person coming in?
I can even throw something.
क्या कर सकते हैं?
I can guess.
Guessing.
Guess करते हैं, क्यों guess कर सकते हैं? Data है आपके पास, right? Humans की height है, जिन तो नहीं आने लगा, hopefully, right? Human ही आएगा ना. So what's the height of the shortest human being currently? 22 inch. 22 inch. Okay. So the shortest human being is 22 inch. What's the tallest guy? Sultan
Pakistani
Kosan used to be, I don't know if, no, that was long.
Alam Chana तो
He
नहीं
died ना. Currently, जिंदा जो है, वो मुर्दा तो नहीं आ Alam Chana died, right? So currently, at least if I remember correctly, it was Turkish guy, Sultan Kosan. He is more than 8 feet. Okay, I don't think मैं लिखा होगा शायद, but I'll just write 8 feet and some inches, I think 1.2 inches. Yeah. So what's the chances that the person coming in is shorter than this guy? हो सकता है कि record ना हो, right? But very low chances, yeah. So let's say ये हम इसको chances, यहाँ high है chance, यहाँ low है, तो इसको हम कहाँ रखेंगे फिर? Low पे रखेंगे, ये तो बहुत ही छोटा है, और बहुत लंबे को भी low पे. इसके अलावा the chances that the person coming in is taller than this guy, very little chance. हो सकता है record ना हो, लेकिन still very little chance, yeah, very little chance here. What are the chances that that person is actually medium height, 5'4", 5'6", 5'7", 5'8"? क्या है?
Huge.
High है, फिर medium से हटते जाएंगे आप तो, जो exceptional heights, exceptionally tall, exceptionally short, कम होती हैं, right? वो हाँ, वो हम उस पे आएंगे. But what I want to tell you at this stage only is that your lack of knowledge does not have to be absolute. There is something that you often know about the situation, right? This situation you know. Now, इसका फायदा क्या है इस knowledge का? It's already here in this room. इसका फायदा यहाँ मौजूद है, right? इस दरवाजे में भी मौजूद है. क्या फायदा है? वो इस knowledge का हमें क्या है?
कि हमने दरवाजा इस तरह कंस्ट्रक्ट किया हुआ है.
हाँ, हमारे दरवाजे जो हैं वो 3 फुट के क्यों नहीं होते हैं? हम सारे ऐसे ही करके जाएंगे या सारे, इस बंदे को तो कोई मसला नहीं है ना. This guy would be happy, right? The rest of us, 99% बिल्लियों की तरह, like cats, we will have to go. Yeah.
Exactly.
So also, why don't we make it like for 15-16 inch? Waste of space. ये कमरा इससे भी ऊंचा हो सकता था, बादशाह लोग बना लेते महल में, right? But it's a waste of resources and space, right? So it's an क्या है? Compromise between, yeah, between using the most optimal amount of material and height. जो ज़्यादातर लोग भी cover हो जाएं, लेकिन सबसे tall बंदे को फिर भी नीचे होके जाना पड़ेगा. But that will not happen every day, right? So it's not that statistical analysis is just for fun to say, okay, we lack knowledge, so we're going to add some knowledge there. No, we then add that knowledge, and then we use that knowledge to make decisions, design. इस डिज़ाइन का हिस्सा है, इस कुर्सी के डिज़ाइन का हिस्सा है ह्यूमन साइज. ये हाथी के लिए तो नहीं बने, राइट? ये जो साइज है, ये जो हाइट है, ये कहाँ से आई है? कि आप बैठेंगे, अक्सर लोग छोटे छोटे होते हैं तो सारों को नीचे से नजर आ रहा होता, राइट? सो this information that we feed in to reduce our lack of knowledge, then we use that information to make some statistical decisions and design values, right? ये ये सिर्फ चार examples हैं. It's heavily used in everything we do in modern times. In our old times, we are already doing these things. Doors वगैरह, windows. Right. So now we come to something that you actually started with. How do we assign probabilities, right? अब वो है कि जी okay, how do we assign probabilities, right? तो कैसे assign करते हैं? You said repeated experiment आप करेंगे, right?
Large.
That's large रखेंगे उसको. तो there are many ways. There is also that the experimentation should be independent, और वो फिर और discussions हैं उस पे आते हैं. But I'll stick to the basic. What are other ways of assigning probabilities? Sometimes we do through actual experimentation observation. Sometimes we do through belief also, right? Okay, I think 10% chance है कि ये होगा. या कुछ चीज़ों में there is so much lack of information that you have to go with some belief. Okay, so we will come to that. Pascal actually used belief and probability theory to prove that it was good, it was or show, at least argue that it was safer to be a believer than not be a non-believer. Okay? वो आप पढ़ना, उसने क्या आर्ग्यूमेंट किया था कि सेफर ये है. वो आप सोचे ना अगर, तो वाकई काफ़ी हद तक इट इज सेफर टू बी अ बिलीवर देन अ नॉन बिलीवर. Pascal is one of the founders of probability theory. But you know, since Pascal and all of that, today we will see how to assign probabilities, and as we see that, we will come across the three axioms of probability. That's the last time we discussed. Axiom is what? The very foundational truths of a system. For this probability system, these axioms are going to be the foundational truths. Truths meaning something we accept without proof. Yeah, क्योंकि उसको within that system to prove that is not possible. So you would be surprised to know when these axioms were written. आपको क्या गैस है कब लिखे गए होंगे? जो probability के foundational axioms है, कब लिखे गए होंगे? Roughly 200 years ago, 100 years ago,
I guess 200 years.
200, 1933. Very new, right? Kolmogorov is the Russian mathematician. You must have heard of him in other mathematics. बहुत बड़ा heavy duty नाम है उस दौर का. He was the first one to formally write the axioms of probability and make a probability theory a proper formal field. Before him, Pascal and others more like gambling की calculations कर ली, छोटी मोटी ये कर ली. It wasn't formally accepted or used, or even there was no formal foundation for probability theory for a long time. So 1933 तो कुछ नहीं है human history में. 100 साल भी नहीं हुए, right? So it's very new, but it
काम इतना ज़्यादा हो रहा है जैसे मतलब एक्सियम्स अभी लिखेंगे हाउ मतलब एक्सियम्स के बगैर ही काम हो रहा था.
हाँ वो तो चलता है ना. आपने न्यूटन ने जब ग्रेविटी डिस्कवर की तो उसके बाद तो नहीं लोगों ने गिरना शुरू किया. People were falling.
The advancement in this field.
Yeah, advancement happened also in the last century or so, or its practical applications in many things. The exercise I gave you last time, those kinds of अंदाजे वाली जो हैं, they were being used, right, for long. People had people had some senses about numbers, about statistics, but to make it so formal that then you can use it in a scientific and engineering applications with much surety, that requires formal structuring. But वो recent है, right? Okay. Compared to rest of mathematics, even the idea of assigning likelihood to something that is random is new. Pascal कोई 400 साल पुराना नहीं है. I think 200-250 है यार, if I'm not mistaken. It's not very old guy. So But even with that, काफी time के बाद in 1933 finally Kolmogorov gave this, which were accepted by majority community and
लाइक फंक्शनल एनालिसिस में भी कोलमागोरो ने जो बुक लिखी वो
जी जी जी
काफ़ी नई
बिल्कुल
डेवलपमेंट
बिल्कुल so काफी fields में उसका right. So how do we? This is our third question today. Yeah. First question was what is probability. Second was why do
How
we
do we
lack
say?
knowledge. So third was what is statistics. So this is actually fourth one. Um, how do we assign probabilities? So you already mentioned one thing. So I will take it systematically. Yeah, and we will cover the axioms in that answer. I don't like कि मैं लिखूँ कि Kolmogorov theorem 1 theorem 2 वो अंदर आ जाएगा discussion के right, it will become part of the discussion. So, first thing, first step. So, I'll do this in 4 steps. How to assign probability. One way is this one in 4 steps. Firstly, clearly define your experiment. Okay? करना क्या, किस चीज़ को assign करनी है probability? बंदे की हाइट को करनी है, बंदे के वेट को करनी है, या टॉस को करनी है. What is your experiment? Right? Experiment doesn't have to mean the thing you do in the lab. Experiment means what is it that you are looking into, right? Yeah. So clearly define experiment. For instance, क्या हो सकती है? Rolling a die, लूडो का जो उसको उर्दू में क्या कहते हैं?
चक्का
छक्का तो आता है ना जब 6 आता है, नहीं यही कहते हैं उसको. I don't know. दाना, हाँ दाना. दाना. Right. Clearly define experiment. आप चित्राली में कुछ और कहते हो?
लूडो ही कहते हैं सर.
नहीं जो वो फेंकते हैं जो दाना.
हाँ,
पंजाबी में
दाना तो कहते हैं.
पैसिक, हम
या-
पैसिक कहते हैं.
क्या कहते हैं?
पैसिक, पैसिक.
Basic. अच्छा.
हाँ.
Right. So yeah, dana is right, and die of course. Die or dice दोनों use होते हैं. Some say dice is plural, some say die is plural, but people ended up using both. So I'll just use die. So experiment is rolling a die. For example, this is the general principle, and this is an example, right? So clearly define your experiment. Let's say your experiment is rolling a die. Okay. Second, define the sample space. Sample space is the universe of possibilities in your experiment. What are the possibilities, right? So to define sample space, this is where usually जब आप probability पढ़ाते हैं तो क्या पढ़ाते हैं सबसे पहले?
सेट थ्योरी.
सेट थ्योरी. क्यों पढ़ाते हैं?
प्रोबेबिलिटी को सर हमने सेट थ्योरी के साथ रिलेट किया. सेट थ्योरी हम प्रोबेबिलिटी से बहुत ज़्यादा मैच करते हैं. दैट्स व्हाई.
And it's
Space
here,
or
right? Sample space
Space.
is a set of possibilities, right? And an event is the set of possibilities of your interest. ऐसे ही है ना? Set is already part है उसका. Yeah, you cannot separate it. So I will call sample space as the set of all distinct possibilities. Distinct क्यों? We will see that. Okay. All distinct possibilities. This is your sample space. So what in this case, what is your sample space?
1, 2, 3, 4.
We will call this sample space or the
Omega.
universal set as capital
Omega.
omega. Within it are your distinct possibilities, right? So let me call them omega 1, omega 2, omega 3, omega 4, omega 5, omega 6, and so on. For rolling a die, how many omegas?
6.
Only 6. But for the general case, they can be more. Yeah. Now, why we are insisting on distinct possibilities? Because you can make others. Agar aap you are interested, what's the chance of having even number? You can combine the even ones and make a new subset, right? So it's good to start with the very basic sets, very basic elements जो repeat नहीं वो नहीं आपस में overlap नहीं है उनका, yeah, distinct possibility. So sample space set theory आ गई, खुद ही आ गई, yeah, the set of all distinct possibilities, yeah. Then each element is what? One distinct possibilities. In this case, what are omega 1, 2, 3, 4, 6? They are omega 1, let's say, is 1, omega 2 is 2, right?
So outcomes तो वो dots है ना, उसको फिर हम number के साथ link करना, that's not comes under random variables and वो चीजें.
क्या चीज?
मैं कह रहा हूँ कि outcomes तो वो dots आते हैं ना हमारे पास. अच्छा, the
Yeah.
number of dots are possible.
No, we are not saying what happened. We're just saying, okay, what are the possibilities if you roll a die? That will be 1, 2, 3, 4, 5, 6. यही आ सकते हैं ना? So I'm just, instead of saying 1, 2, 3, 4, 5, 6, I'm starting with something general.
Yes.
Right, that's it. अभी हम वो experiment नहीं कर रहे हैं. Right, so define your sample space. This is your sample space for rolling a die, and I could also write it as set omega 1, omega 2, omega 6, where this set is 1, 2, 3, 4, 5, 6. Right? I'm not saying which one is going to come or what's the chance. I'm just saying these are the possibilities. I'm just writing the possibilities as a set. Right? And each element I'm just going to give it a name for generality. Yeah, general Acha. Third thing, define your events. Event or events. Okay, so how do you define your events? What is an event then for us? Yeah, normally क्या कहते हैं हम, what's the probability that it's an odd number? So the set of odd numbers from within this, yeah, सारी दुनिया के नहीं लेने हमने, इसके अंदर से, yeah, that will be one event. और क्या event बना सकते हैं आप?
The set of evens we can say.
What else?
The set of less than 5, less than 2.
देखिए ना क्या set theory आना शुरू होगी, वो क्या है इसके subsets है ना, including null and this guy itself, right? So ये तो वो सारी set theory आना शुरू होगी, it's in there, set theory is there. So define your events. Events for our purposes is this. We're going to say an event is a subset of omega where event is subset of omega including phi and omega. Doesn't have to be proper subset, it can be an improper subset as well. Yeah. So we will not go into details of all that, but आपको पता है, yeah, subset of omega is here. Okay.
Why is including null sets here?
Null, we want to have the जो impossible या जो event है, let's say you say कि जी what is the probability that none of them happen, right? So वो just we'll see, is sometimes useful, right? So I'll write this mathematically also from here. Let's say there is an event A. सेट्स की आप नोटेशन पढ़े थे, बिल्डर नोटेशन, याद है? तंग होते थे सारे, क्यों पढ़ाते थे लोग, अभी काम आई. So X is one of the omegas, okay, such that omega satisfies some condition. Since this can be so many, अभी आपने बताया ना, it could be A is omega such that omega is even, A is omega such that omega is less than 4, right? Now वो जो null set है, somebody say A is omega such that omega is negative. ठीक है? Now in your die rolling experiment, what would A be? Null हो
If
जाएगा.
null, yes.
हो जाएगा ना? तो आप अलाउ तो करना चाहते हैं, उसकी भी probability दे दें कि zero है, मसला तो नहीं है. But if you don't allow null set and somebody writes this set for you and says, okay, you're rolling a die and A is omega such that omega is less than 0 or is a negative number, yeah, even 0 भी नहीं होता उसके अंदर, right? So
Greater than 6
yeah.
we can say.
हाँ, there are many ways you can get a null. So you want to allow that.
Include, yes.
There are many ways you can get omega itself. क्या है?
Oh,
A is omega such that omega is integer.
integer.
सारी आ जाएंगी राइट पूरा ओमेगा है इस
Mega is equals to mega.
वो तो है और ओमेगा सच दैट बिल्कुल itself इक्वल है ओमेगा इज larger than smaller than 6 smaller or equal to 6 तो फिर वो सारे कवर हो जाएंगे या so that's why we want to allow this yeah we don't want to exclude that so अभी क्या हो रहा है here I am writing the general statement here I am giving you example and here I am writing it in set theory साथ साथ चल रहा है सारा कुछ ठीक है बनता जा रहा है universal set elements of the universal set which are distinct possibilities and then special subsets of that including null and phi itself yeah so अब आपके केस में मैं लिख नहीं रहा लेकिन you know a can be omega is even so then what is omega 2 4 6 why not 8 that's the part of the definition it has to be omega पहला तो उसका ये काम है ऐसे नहीं कि सारे इवन नंबर लिखना शुरू कर दिया so okay right so then what two events look like in pictures basically then events are basically इनके है ना तो ये हो गया एक इवेंट ये इवेंट हो गया ये खुद तो सारे ही इवेंट है ये पूरा भी एक इवेंट हो गया ये भी एक इवेंट है था ना a omega such that omega is a negative number खाली आ गया yeah so you can make it so there could be events can be overlapping events को तो कोई मना नहीं है सिर्फ distinct possibilities cannot be over because by definition we want to start with the very basic distinct yeah लेकिन उसके अलावा other than that the events can be overlapping कोई overlapping event बना सकते हैं rolling a die के लिए a और b दो events बनाएं क्या बनेंगे overlap हो
A और B दो events. हमारे पास जो
both
die
are
करें
both are even number
वो तो फिर exactly overlap a equal b कर दिया आपने
2 से
Right.
greater हो 4 से less हो
yes
okay 2 से greater हो हाँ that's
Yes,
fine
yes, yes.
you could also have a saying that omega such that omega is an even number and b saying omega such that omega is less than
less than 4
5
yeah,
let's
5.
say तो उसमें क्या overlap आ जाएगा 2 और 4 का
Mhm.
right so there can be many ways of having this thing but graphically how does it look बड़ा प्यारा ये मजे का है this is the universe
Yes.
that you are working in right these are the distinct possibilities in your universe right then events are basically some collection of this which could be even zero or the whole thing or even individually or whatever subset जो वो subset की theory तो पढ़ा दी ना फिर आप उन्होंने पहले से right so you know now we come to the real part this was just setting up the whole thing question क्या था how do we assign probabilities right so that is the real question now how do we assign probabilities this is just setting up अब ये साइन तो नहीं की मैंने कोई दिया है कि ओमेगा 1 की क्या प्रोबेबिलिटी है एक आपने तरीका बताया एक्सपेरिमेंट्स कर लें वो भी हम उस पर भी आते हैं बट थर्ड इज जिसको हम फोर्थ कहते हैं इसका फोर्थ पार्ट assign probabilities now this can be done based on experiments right or some belief system which is leads to Bayesian statistics we'll look at that later but here I want to keep it very general so I'm going to say assign probabilities what do you mean by probability probability is from similar to measure theory होती है you assign measures to norm is a measure right similarly this is a you want to assign some measure to this thing measure calculation which leads to some numeric values for example assign probabilities such that they make sense This is where the axioms come in. Axioms को proof तो नहीं आप करते, right? क्या करते हैं? Self-evident truths, meaning they make sense. ये
लॉजिक्स पे
so I want to keep it general, then we will see how the frequentists they assign probabilities using repeated
Repetition.
experiment, and the Bayesians how they try to do it. Yeah, you can see that. But for now, I want to say this very simple thing: assign probabilities such that they make sense. Now, this is where Kolmogorov comes in. Till 1933, there is no what makes sense. Okay, क्या होना चाहिए set of rules. Yeah. कुछ कुछ तो समझ आते हैं, लेकिन हाउ डू यू मेक अ सेट दैट इज सफिशिएंट, रिपीटिशन ना हो उसके अंदर, वो सारा कुछ ना, सेट ऑफ एक्सियम्स. सो दिस इज वेयर कोलमोगोरोव कम्स इन. देयर आर थ्री एक्सियम्स, मीनिंग थ्री एस्पेक्ट्स ऑफ मेकिंग सेंस. ऑल थ्री शुड बी मेट इन व्हाटएवर वे यू असाइन प्रोबेबिलिटी. तो अभी हम आपकी असाइन प्रोबेबिलिटी असाइन करने का कॉन्स्टिट्यूशन लिख रहे हैं, आइन लिख रहे हैं, नॉट एक्चुअली असाइनिंग प्रोबेबिलिटी, right? We're writing the rules that need to be followed, right? And those rules are based on what makes sense. Those are the three axioms. So I'll go to the axioms now. कोई आप guess कर सकते हैं जल्दी से? Maybe you can think like
probability is
Kolmogorov.
always going to be positive and it's between 0 and 1.
Okay,
The
that's
maximum
one.
outcome that we have is 1.
Let me take some of this away. और क्या आपके दिन में आता है?
The probability of space is equal to 1. जो sample space है.
Occurrence cannot be negative of some.
वो तो बता दिया ना. हाँ.
Sample space की probability 1 होगी पूरे.
सैम्पल स्पेस की 1 होगी. गुड. और
सेट की जो है 0
नल सेट की 0
0
होगी. वो कुछ जो है ना एक दूसरे से डिराइव हो जाते हैं, इसलिए वो हम ठीक है. दैट्स वन, लाइक विल कम टू द मिनिमम सेट, बट ओके दैट्स फाइन. और
Summations of probabilities of all subset is going to be 1.
वो दैट कवर्स इंटरेस्टिंगली वो दैट कवर्स दैट द होल p probability of this omega should be 1, राइट? ओके. और कोई आता है जिनमें एक है जो थर्ड एक्सियम है, थोड़ा सा सोचना थोड़ा सा मुश्किल है, right? So we will come to that. But you're right. So the first axiom, probabilities cannot be negative. क्यों?
Doesn't
Right?
make sense.
हमें जो the sense we make of chances, it can be 0, 1 or in between, but negative doesn't make any sense in this context, right? So that is the first axiom. Probability of any given event should be. अब किसी ने कोई ऐसी somebody gave you an event that wasn't possible here. Okay, null set आ गया, 0 दे दें उसको, but not negative. Yeah. Okay. What else?
Probability of space.
So I'm not writing the whole statement. You have my notes and you can also see the book, but I'm just writing the maths here. Probability of A is what? The event, one of the, or any event actually, right? So this is what omega, so that omega satisfy. Okay, and it has to be true for any event. What's the second one you mentioned? That was probability of the
Omega is equal to 1.
yes, probability of omega should be 1, right? What does this also cover? When would the probability of omega not be 1? कोई एक example बता सकते हैं आपके?
When the subset.
Subset?
Like
No, we're talking about omega, not subset. Omega तो पूरा है ना. So what would cause this to fail? क्या गलती होगी आपसे?
क्या आपने ओमेगा से डिफाइन नहीं किया?
एक ये है कि let's say I'm rolling a die and I say that my universal set is 1, 2, 3, 4, 5. एक भूल ही गया मैं, right? That's one basic reason that could happen. What is that? That you forgot to cover some possibilities. आप समझ रहे थे कि वो impossible है, पर वो भी थी अंदर, तो फिर तो p omega 1 नहीं होगा. Other reasons would be that let's say you say that this has possibility, each of these has possibility 1/4 राइट तो क्या होगा सारी वो 100 से ऊपर चली जाएंगी जमा करके 6 है ना
Yes.
1/4 each करेंगे तो will be above so something went wrong inside so there may be many reasons but one important reason that I just mentioned is that it all this thing also includes that you have enumerated all the distinct possibilities ये तो key है अगर आपने कोई if you miss some distinct possibility then this cannot be one मतलब you will make mistakes there yeah okay third axiom this is interesting is that probabilities assigned to mutually exclusive events must make sense okay mutually exclusive event क्या होते हैं पढ़ा हुआ आपने basic you have studied in basic
mutual exclusives are non-overlapping, you can say.
non-overlapping
Disjoint, you can say
Disjoint.
so you're talking in sets
Yes.
right now talk in probability
someone that are, you can say, doesn't match with each other. There's both streams. Someone I'm saying that's a set of even number and set of odd numbers.
cannot happen at the
At
same time
Yes.
right ठीक है yeah
Yes, sir.
cannot happen
At the
वो
same
mutually non-overlapping that's the set manifestation of what you're saying but in terms of probability and happenings what is it two events that cannot happen at the same time so that should be here right आपने ऐसी if you this P is your probability measure from the measure theory kind उससे related so essentially probability theory is basically this P this omega and there's one more thing but I think we'll not go into that much detail but what is it what did we say the probability of mutually exclusive events must make sense so how did Kolmogorov write that thing say if A and B are mutually exclusive then probability of A union B yeah should be what
A plus
A plus
probability
B.
B.
yes Q there is no overlapping part right so there shouldn't be any third term here right because from set theory you know that A union B is just A and B put together there is no repetition ऐसे ही है ना so then it should be just this thing nothing here there are cases when these are not mutually exclusive and then you need something here we'll come to that right but for now when we say that A and B are mutually so cannot be negative total probability should be 1 right so that is simply saying between 0 and 1 yeah thirdly this is very interesting you cannot assign a measure so that it fails this test क्योंकि वो तो फिर it won't make sense right so A and B are mutually exclusive if they are mutually exclusive then if they are exclusive then this should hold other if your whatever method you use to assign this measure P to these events if you know they are in mutually exclusive and it does not equal their individual sum something is wrong doesn't make sense axiom is violated yeah so that is the these are the three axioms and we will see with the experimentation and how you assign probabilities but this covers the general principles of a so what was it first define your experiment अंदर तो बात नहीं करनी कि अब किस चीज़ को साइन करें आप you should know किसको करनी मैंने साइन when rolling a die is a simple example but in real experiments it could be I'm saying I want to assign probabilities to my voice what are the chances that my voice has this frequencies
So, sir, first of all, our experiment is our, you can say, the first priority that is experiment must be clear for us.
yeah otherwise आप देखिए ना if your experiment is not clear can you define what is possible in that experiment नहीं कर सकते ना, अगला स्टेप ही नहीं होगा आपसे, क्या करेंगे? सो यू हैव टू हैव क्लैरिटी अबाउट व्हाट यू आर गोइंग टू वर्क विथ, क्या चीज़ है जिसको आप असाइन करना चाहते हैं.
We must have a certain experiment that will know exactly.
Experiment, problem statement,
Okay.
right? That thing you should have. Second,
सर वैसे ये रैंडम चीज़ें हैं, कुछ चीज़ें प्रोसेसेस रैंडम होते हैं, जैसे हमने कहा बहुत ज़्यादा ऐसी चीज़ें हैं, तो रैंडम चीज़ तो क्लैरिटी डिफाइन हम कैसे करेंगे? लेट्स सपोज कभी कभार ये है कि हमने कोई एक रैंडम इवेंट आ गया, so we don't know what are the outcomes.
no,
Very,
rolling a die
hmm,
and tossing a coin, दोनों random है,
yes, yes,
right?
yes.
Now, आपको अगर ये, if you don't know which one of these you are going to work with, are you going to assign probabilities of heads or tails, or are you going to assign probabilities of seeing an even number on a die,
So,
right?
so, yes,
In that sense,
yes,
right?
yes,
You should know what you want to do. And to make things interesting for students in the exam, we combine these also, right? You roll a die and toss a coin. What's the chance that you get 4 there and a heads here?
yes, yes.
Okay, so you can combine that. Then that is your experiment.
Yeah.
First, decide what is your experiment. Is it tossing a coin 2 times? क्या होता है उससे sample space को क्या आ जाता है? वैसे H और T है.
H or T.
If you do it 2 times, it's what? HH, HT, TH. Change हो गया ना?
Yeah.
This is what we're talking about, right?
Yes, yes.
I'm going to toss it 10 times.
Mhm.
Okay, then sample space एकदम further change होगी. So that is what we mean. Then define your experiment, define your sample space, the universal set, this big omega guy. Define events in that,
Mhm.
जिनको assign करनी है आपने probabilities, right? And finally, make sure that your assigned whatever methods you use, what you end up with, the assigned formula हो, कुछ भी हो, calculation or whatever you're doing, it should
Follow
make
these
sense,
axioms.
follow these axioms, right? Then you are mathematically, scientifically sound. वरना फिर कोई मसला है उसमें, right? So let's see, we had time थोड़ा. So we come to our next question. So far we have assigned probabilities here, yeah, okay. What is a joint probability? It's just a revision, so I'm just asking all of these things. You know joint probability क्या होती है? कैसे explain करेंगे? How would you explain it?
Occurrence of two events at the same time.
Right.
That is going to be joint probability of two events in
Yes.
an experiment.
Right. So the chances of two events happening at the same time. And we said it is 0 for what kind of events? Mutually
But
exclusive.
Yeah.
Other than that, there can be some overlaps in the set which will lead to some chances of them happening at the same time, right? So sometimes we are interested in finding probability of two events occurring at the same time. We will see real examples in why we need that, but here I have this example that
Achha, sir, for the same experiment we are interested of two events at the same time, or there might be two different experiments and we take one event from one experiment and two, then
they can be two different experiments, but then what you are looking at, the whole experiment contains those two.
okay.
Right? That's when you can toss a coin and go. You will say, agar to those things are independent, then you can try to calculate what are the probabilities that you get a heads and a 4. Right? वो भी एक joint है ना. But those two experiments are now part of your bigger experiment. It's the biggest one that you want to look at. Right? So yes, definitely it can be. It can be composed of several sub experiments. Right? That's fine. Acha. So let's say I say I've written here A. Ali is in lecture. Ali तो नहीं आप में कोई आप है? ओहो ये पिछले साल का लिखा हुआ है तो अब विल कंटिन्यू उस वक्त कोई नहीं था. Right. So we say the A is Ali is in the lecture and B is Ali is sleeping. Yeah, so what is probability A and B? Right? This is how we write it. You can write it like this also, P, A and B, the joint probability. What is that? That probability लफ्जों में क्या होगा ये?
Disjoint
हैं? नहीं सुनी तो नहीं।
हाँ
आपने मेरी क्लास
अरे
में बच्चे सोते नहीं
लफ्जों में क्या
देखा? बड़ी क्लास बिग क्लासेस ना पीछे दे स्लीप,
Yes,
right?
Ali is in the lecture at the same time he's sleeping.
So how would you read it? Yeah,
Ali
Ali
is
is
sleeping
sleeping in the
in the
lecture.
lecture.
Yes.
Simplest to you. Right? So that is probability A and B. Two things happening at the same time, right? So Ali is sleeping in the lecture. Right. What is conditional probability?
Conditional probability is sometimes that uh, if we are interested in A when the B has happened, that's a conditional probability. Something we are interested of probability of A when B has happened. That is a conditional probability of A when A.
Right, so it has happened. So I like to, it's very right, and I like to say it like this. I like to connect it to the knowledge thing, lack of knowledge, all of that. Yeah. So in this case, conditional probability for me is that sometimes knowledge of occurrence of one event, right, helps us assign probability to another event. या उसकी वो lack, it reduces the lack of knowledge, can reduce, doesn't always, we will see that also. Yeah, so that is where conditional probabilities come in. What is it? Sometimes we know that an event has occurred, as you say, B has occurred. Now why don't I use that information if I can, if it is a useful information? We will come to that. When is an information useful? हमेशा useful नहीं होती, right? But if it is useful to my certain situation, then I can use that information, put it into my system, reduce the lack of knowledge. यार कहानी तो वही थी ना, lack of knowledge होता ना तो ये हम थ्योरी पढ़ ही ना रहे होते, या यहीं से शुरू. So that for that conditional probabilities come in and they're very handy, very useful. In exams and things you see like, yeah, why are we calculating it? But believe me, in the real world, the actual probabilities are used very little. सारी conditional पे काम चलता है. A lot of it. अच्छा, it's, we know this, then what is the chance that that will happen? Yeah. A lot of it goes on conditional probabilities, right? So let's say अब ये वही अली ही चल रहा है, I'm sorry. Ali is in lecture at 8 a.m. right? एक event है. Ali is in lecture at 8 a.m. B, Ali is sleeping at 8 a.m. Right? Now, what would be, how would you read probability A given B? ये होता है conditional का आपको पता है यार, so I will do that. What does this mean?
Well, let's first clear that Ali is sleeping at home or at the class.
Doesn't matter. Right? In this case, if you want to read this, while Ali is sleeping at 8 a.m. Right? So what would this probability be saying?
Probability that Ali is in lecture at AM,
Where Ali is sleeping.
given that
Given
Ali
Ali is sleeping.
Ali is sleeping at AM.
So he's given, what are the chances that he's um, in lecture when we know that he is sleeping?
Yes.
कम हो जाते हैं ना बच्चे, क्लास में सोते हैं लेकिन बहुत कम होते हैं, ज़्यादातर घर में सोते हैं, right? Then they miss the class sleeping. Yeah. So I want to distinguish it from probability A and B. Now, interestingly, you could also read this. What would this be? ये अब different हो गया.
Yes.
क्या है? Read it. अल्फाज में. What are the chances that
Ali is sleeping,
sleeping
at 8 AM
where Ali is
when we know that Ali is in the lecture.
right? So he is in the lecture. What are the chances that at 8 a.m. we know he's in lecture? What are the chances that he's sleeping? Right? So this is where probabilities, conditional probability. This is just to give you an example of how A and B. How is it different from A and B? Probability A and B.
So in A and B they are like overlapping, that they are occurring at the same time. But in this case, we know one has occurred, but we don't know about the other one.
Yes,
We are going to
that
find.
here we don't know about both. So in a way, they're both
Mm.
currently lack of knowledge.
Yes.
Here, lack of knowledge from one has been removed. We are
Yes.
claiming that it has happened, right? So you're right. Here, both are, in a way to say, both are currently unknown. Here, one is known,
Other is
and we want to use that knowledge to try to say something about
the other.
the other. Yeah. Okay. So another example. Suppose that I write an integer from 1 to 4 on a piece of paper. Yeah. So I tell you that I'm going to write 1 to 4 integer. Yeah. 1.5. Yeah. 1, 2, 3, 4. I don't show you. ठीक है? Now what is the probability that I wrote 3?
First we look at the experiment,
Hmm.
and then we'll
One
look
by
at the, what
four.
are the possible outcomes,
Hmm.
and then we'll assign probability. That's a fair. Then we can assign 1 by 4, so that's going to be 1 by 4.
Right. There is 1 by 4, and you have actually included some belief in there. You know, क्या belief डाला आपने?
Fair आपने मतलब
Fair है या ये कि मेरी natural disposition is like that. Maybe I like number 3 too much. I mostly pick number 3 or write number 3, right? But you put some. I wanted to connect it to that thing where I said sometimes or often we also need to put some belief in there क्योंकि prove नहीं कर सकते ना आप बहुत सी चीजें, right? So yeah, you're right. With that belief and this setup, it seems it should be 1 by 4, right? So the probability that I wrote 3, now in this experiment, I will say A is that I wrote 3. That's the event, yeah? That is 1 by 4. Probability of A is 1 by 4. Okay. Now let's say I tell you that I have written an odd number. So B is wrote odd number. Yeah. And I tell you that B has happened. Okay. Then I'm asking you to find probability that what's the probability that I wrote A given that B is true. Yes. Then what is it?
1 by 2.
1 by 2. कैसे पहुंचे? Logical है, simple है, but let's connect it to the bigger set. हुआ क्या? What really happened? पहले ये बताएं, did the probability, did the lack of knowledge go up or down?
lack of knowledge कम हो गया सर.
कम हो गया ना, चांस आप कह रहे 50% चांस हो गया. यहाँ पे आप कह रहे क्वार्टर चांस था, यानी भी और भी अनसर्टेनिटीज हैं जो हो सकती हैं, बट हियर यू रिड्यूस द अदर सेट, वो आधा रह गया, अब ये आधा, राइट? तो दैट्स अ गुड थिंग, राइट? फ्रॉम आवर पर्सपेक्टिव यही तो था, लैक ऑफ नॉलेज ही को तो हम पुश करने जा रहे थे पर
Sample size को मैं छोड़
दैट्स द थिंग. व्हाट हैपेंड हियर इज वेरी इंटरेस्टिंग. Your original universal set or sample space was this thing, right? This is what you started with, isn't it? But this knowledge, what did this knowledge do? That I told you that B has happened. What did it do to your universal set?
shrink.
Showing that will go 1 to 3. Sample
It-
place will reduce.
Yeah, it shrunk it, right? This is, let's say this is your new sample, your new universe now, right? So a good information, we will see what a good information means. Yeah, that a good information, what does it do? It reduces your sample size, and because of that it leads to reducing the lack of knowledge. अगर मैंने आपको ये बताया होता कि I wrote a number less than 5, ठीक है?
Then
What is probability A given B?
1 by 4.
1 by 4. Information दी मैंने आपको,
but sometimes
useless थी, थी ना useless इस
Yes.
केस में, right? Yeah. Yeah, information can be useless in multiple ways. Yeah, here it was useless in the sense that it did not reduce your universal set. It can be useless in the sense, वो हम फिर शायद आगे में है आ रहा है. That is linked to independence
हम्म,
of information, right? और तो आपने पढ़ा independent events क्या होते हैं. Mutually exclusive हमने देख लिया, right? ये देख लिया.
सर जो कोलमोग्राफ का जो एक्सियम्स थे
हम्म.
all are they based on the uniform random numbers? क्योंकि अगर हम नॉन यूनिफॉर्मिटी लेके आ जाते हैं, जिस तरह अभी आपने कहा कि व्हेन आई राइट लेट्स सपोज आई लाइक नंबर 3, तो उस बेस पे अगर मैं
नहीं
कर
नहीं नहीं,
देता.
कॉल्मोग्राफ इज नॉट अफेक्टेड बाय दैट. उसमें तो कहीं था ही नहीं ऐसा कि आप जो कह रहे हैं ना वो इक्वली लाइकली की बात करें.
एग्जैक्टली.
नहीं,
तो उस
उसमें आप उनको दोबारा पढ़ें. देयर इज नथिंग सेइंग दैट देयर शुड बी. इट्स टॉकिंग अबाउट नॉन नेगेटिविटी. इट्स टॉकिंग अबाउट द टोटल सेट.
यस सर, बट द लास्ट वन
राइट. म्यूचुअली एक्सक्लूसिव में भी क्या मसला है? So if events are mutually exclusive, then their joint probability, right? So the combined probability A union B should be PA plus PB, no matter what. अगर कुछ, let's say I assign कि जी 50% of the time I write 3 and the remaining 50% is equally divided between 1, 2 and 4, these 4 numbers. Even then PA union B has to be satisfied, right? So उसका उससे कोई नहीं है. Try कर.
असाइनिंग प्रोबेबिलिटी की बात करो सर.
हाँ.
असाइनिंग प्रोबेबिलिटी का अगर हम
नहीं.
इक्वली लाइक ना भी करें तो दैट फॉलोज.
That will be fine, yeah. वो axioms are not affected. वो फिर तो limit हो जाएंगे ना, right? So we can check that. But before we go to um, too much independence thing, I just want to write here something interesting. So ये तो आपको समझ आ गया. Useful knowledge reduces that set, so it reduces the lack of knowledge and gives you, and this is very useful, probability A given B. There is a link between probability, conditional probability and joint probability. क्या है link हो? एक formula है.
Yeah. Probability of A given B is equals to probability of A intersection B divided by probability of B.
Right? Now, is there a condition?
Probability of B should not be equal to 0.
Right.
Yeah.
वरना mathematically भी problematic है. But can you make sense of this? Mathematically तो नजर आ रहा है. What else can be the reason?
The
Logically.
event should be like not impossible event.
Right. Why? क्या हमें मसला क्या है? Logical. Where is the logical inconsistency that requires this? Mathematical inconsistency तो नजर आ रही है ना. 0 से divide नहीं कर सकते आप. What is the logical inconsistency? Words में. Always remember, if you cannot connect your equations to words, to logical explanations, you don't really understand that thing. पूरी नहीं समझ आई अभी. वो तो कोई भी बच्चा भी बता देगा कि 0 से डिवीजन नहीं होती, right? तो एक रूल हो गया ना मैथ का. That doesn't mean we understand what is happening in this particular case, right?
Because if it's impossible event, then we can relate with A actually. Then it doesn't affect A.
So in first case, when I was saying that probability A given B means that we know the probability of B and we are going to find out A based on B. But here we don't know actually the possibility, the probability of B.
So that's an impossible event.
So this is the logical inconsistency. Look at the left side. You are asking me to calculate what is the probability of A given that B has occurred,
Yeah.
right? And then you suddenly tell me that B was impossible.
Yes.
If PB is 0, that means you're telling me B was impossible. Which is correct? Are you telling me B has occurred? Or
Yeah.
was B impossible? Cannot happen at the same
Same
time.
time.
This is a logical inconsistency. You were lying to me, right? Or cheating me or something. One of these statements is not correct. So, logically also, I cannot find this thing, because if your claim is that B has occurred, and then you add another claim on that PB is 0 means it was impossible, then how did it occur?
Yes.
You provided me wrong information, you cheated.
When you're saying B has occurred, then it means that it gets some values greater than 0. That means?
No. It means that in this case we don't assign B any value here, right? All we are saying is that you tell us that B has happened with certainty. That doesn't mean that the probability of B was, before the experiment it was 1. It doesn't mean that. It had some chances of happening, but now I know that it has happened, right? So that is this probability of B at the start of the experiment, right? And then you told me, okay, B has occurred, like here I told you, okay, B has occurred, right? So, but I could also still, before B happening, what is the probability of B, by the way, in this case?
Probability of B is actually 2 by
Huh?
4, 1 by 2.
1 by 2, yeah. तो उसकी probability तो थी. It only becomes certain when I say that P A given B, right? I say it has happened. Then what it does is, if you want to solve it with the formula, then PB comes in. If you want to look at it logically, you don't even have to go there. You can see that the universal set has shrinked if the information was useful. अगर वो useless information थी, then this universal set will not shrink. For example, I tell you that
Less than 5.
hmm?
Less than 5.
That was one thing. Another way is that I tell you that there is an event C that I had 2 cups of tea. ठीक है? Now what is the probability that I wrote 3 given C? Yeah? कोई ताल्लुक ही नहीं है उसका. Yeah? This is information.
Yeah.
This case may it is also useless, right? So we will see that what does this mean when we come to independence. Also, I think we are almost there. So what is statistical independence? When are two events independent?
Two events are said to be independent when they doesn't affect the probability of one another. Then we could say that they are independent.
Yeah. So in our cases, we say two events are independent if the probability, if the knowledge of one does not affect
The knowledge of
Yeah,
other.
creates of others.
the probability measure of the other, right? So in this case also the C thing is useless for us. Also I've written here, wrote a positive number, so then probability A given C is still, if I say C is that I wrote a positive number. In this case it is still not helping me at all. Yeah. So there are two ways of writing this thing, of showing that one is probability A given B equals probability A. Then A and B are independent. Okay, that's one thing. Statistically independent. So what other way is there to show this from this thing? Probability A intersection B should be
Probability of A, probability of B.
right. So it should be separable, right? Yeah. Na? Where does this
Yes.
come from?
We can write by T diagram. We can see.
You could try, or simply here.
Yes, yes.
ये तो था ना? Right. So if this holds, that means you can put PA here, then PA intersection B is PA times PB. So there are two ways of showing. This is more basic, and then there is
So how can we define a difference between mutually exclusive events and independent events?
अभी बताया ना, mutually exclusive.
Cannot happen at the same time.
Actually, are mutually exclusive events independent or dependent, by the way?
May be dependent or independent.
No. एक जवाब है, आप probability पे probability लगा रहे हैं. Maybe. Right? सही है. Really, there is one answer. Mutually exclusive events, are they independent or not? What's the concept of independence? क्या बताया मैंने? When the
Yeah,
knowledge of one does
does
not
not
affect the probability of other.
Yes,
Right.
yes.
Mutually exclusive events are
So this is
dependent.
actually mutually exclusive.
Dependent.
They are very dependent. क्योंकि once you know कि आप पता है they are mutually exclusive and one of them has occurred, दूसरे के क्या चांस रह गए? Zero.
Mhm.
Mutually exclusive थे ना, right? So basically knowledge of one changes the probability of the other, right? So
ओवरलैपिंग और उसके अंदर कोई डिफरेंस है मतलब देखो सर प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी इट इज प्रोबेबिलिटी ऑफ बी प्रोबेबिलिटी ओवर नॉन
वो ए
ओवरलैपिंग के
यूनियन
केसेस
वो आप ए यूनियन से कंफ्यूज कर रहे हैं ना. Mutually exclusive is that they cannot happen at the same time.
ठीक है
Independence is that knowledge of one
हम्म
does not affect. जरूरी नहीं है कि वो जो मैं बता रहा था ना कि लैक ऑफ नॉलेज को रिड्यूस करना वो तो है कि यूजफुल है या नहीं, बट इन जनरल इट इज दैट knowledge of one does not change the probability of the other. This is what this statement is saying. So इसको पढ़े. Probability of A. What is the probability of A? What is the probability of A when you know that B happened? Is still probability of A. मुझे तो कोई फायदा ही नहीं, कुछ कोई change हुआ ही नहीं उसके अंदर, right? But for mutually exclusive, what will happen if A and B are mutually exclusive, and I tell you probability of A given B. B has happened. A was mutually exclusive. A can never happen now, right? So वो zero आ जाएगा. So mutually exclusive are actually dependent. Okay. Independence has to do with change in the probability of the main event here, in this case A, right? So probability A given B is still the same, then we say it is
डिसजॉइंट के अंदर कोई इनकी रिलेशनशिप्स आ रही है सर
डिसजॉइंट से नहीं है, इसका कोई ताल्लुक नहीं है. वो आप A यूनियन B से कंफ्यूज कर रहे हैं ना, वो भी हम देखेंगे उसको भी, उसकी फार्मूला. लेट्स सी मे बी आई थिंक हाँ काफ़ी हो गया टाइम. सो वी विल कंटिन्यू विद द स्टैटिस्टिकल इंडिपेंडेंस एंड देन वी डू सम मोर डिस्कशन ऑन म्यूचुअल एक्सक्लूसिविटी. एंड वो जो आप कह रहे हैं ना ओवरलैपिंग वगैरह आ रहा है वो, राइट? ए यूनियन बी क्या होता है? प्रोबेबिलिटी ए यूनियन बी अगर म्यूचुअली एक्सक्लूसिव ना हो तो
प्रोबेबिलिटी ऑफ ए प्रोबेबिलिटी ऑफ बी प्लस
माइनस माइनस
माइनस
वो है वो जो ओवरलैप को निकाल के बाहर फेंकता है, वो जो आप कह रहे हैं ना. इंडिपेंडेंस को आप इस तरह आई कैन शो इंडिपेंडेंस फ्रॉम हियर कि वो श्रिंक नहीं हो रहा किसी वजह से,
ठीक
right? वजह क्या है? There could be different reason. As I said, the information could be totally unrelated to this, or the information could be so general that it covers the whole omega again, so कोई फायदा नहीं हो रहा. That is where independence comes in. Independence को इधर से ड्रॉ नहीं, मेरे नहीं हाल आप कर सकते हैं
ठीक
उसका,
ठीक
क्योंकि उसका ताल्लुक उस बात से नहीं है. वो that is related to mutually exclusive or not exclusive, overlapping, वो जो आप बता रहे हैं ना. So yeah, we do that and then inshallah we will do total probability or something. Again, this thing in undergraduate is like जो अभी अगले lecture इसमें हम करेंगे, that is normally 5-6 lectures तो बन ही जाते हैं. Yeah, I'm summarizing क्योंकि I hope you know recording भी है, देख लें दोबारा भी सुन लें. कोई questions? चले अभी हम अभी हैं सवाल वगैरह मज़ीद नहीं? Good.